two guys, and then we'll get started here. Alrighty guys, welcome. How's everyone enjoying OSCON so far? Good? Very good. Good. So this is probably one of my more favorite talks, I guess, because it gives me a lot more opportunities to kind of leave the reservation from what's on the slides and talk about a lot of the experiences that I've had. And it's a lot more fun to be can actually kind of start to address specific things that you guys have. So to that, before I get started, I just wanted to say, as we go through this, if there's something specific that you want to take a little tangent on, that's okay. We'll get through a bunch of these, at least 10, and we'll hopefully have some fun with it. So, for those of you who do not know who I am per se, obviously I'm John Lagershon. How did I involved in the open source things like this? I was originally, it says here, I was Chief Technology Officer of a company called Automotive Computer Services. If you're involved in open source, that probably means absolutely nothing to you. I recently took this job. ACS is a company that sells software to car dealerships. So what I'm basically doing now with my time is we're building a Web 2.0 platform to manage car dealerships, so car services and kind of all that stuff. Interesting project in the sense that it doesn't have a lot of what I consider, and this is my personal opinion, mundane problems of typical web app development, making sure it scales really well. My maximum user base is 100,000 people. And the business model is based on just generating traffic revenue and things like that. In my former life, I was the senior architect for Zen's Global Services, which is when I actually started putting together and presenting this talk. In my life at Zen, I was basically responsible for working with pretty much any major PHP application that you can think of on some level or another over the years. And this talk was actually designed as kind of an accumulation of my experiences there, at least a subset section of them, and just what I saw people doing all over the place that were kind of wrong and broken that they shouldn't do, and what kind of things, just in general to improve and sort of what worked, what didn't work, things like that. I'm actually much more interested in this topic now than I was when I worked at Zen, because as the CTO of this new company, these are all things I'm trying to avoid in my organization. And also the PHP 5 Unleashed, that's actually available down in the little bookstore. If you guys want to pick up a copy, I'll sign up for it. I would help for the Zen certification exam for PHP. I was involved in that. Of course, I do a lot of speaking, contribute to PHP, et cetera, et cetera. So that's a little bit about me. Let me talk a little bit about this talk. What do I mean when I say scalability? Now, most people make the mistake of thinking of scalability to equate the same thing as high performance. It's scalable. It's not just, or they think it's all about just faster performance or things like that. Scalability to me, I like to define it as something else. I like to define it as the ability and flexibility of an organization to meet the growth requirements of that organization. So it's more than just making things faster. It's how do you go from a dev team of 2 guys in a garage to a dev team of 300? How do you make that process work? How do you make things faster? Is definitely part of it. How do you scale your hardware? How do you scale your data needs and everything else? And I also like to point out that the fastest quote-unquote approach when it comes to performance is not necessarily the most scalable approach. And a good example of that is object-oriented programming. OOP is by definition, because of the nature of OOP, slower than procedural programming. there's more structure, and therefore more stuff that has to happen in order to do it. And if just speed was the only thing that ever mattered to anybody at all, we still would be numbers, right? So it's not just performance. When we talk about scalability in general, the types of things that I'm going to say are wrong, the counterpoint to that, the right answer is that when we talk about scalability, you've got to think of everything in terms of what can I reproduce over and over again at greater and greater scales. And moreover, it's also got to be regardless of size. It's perfectly reasonable, in fact, it's strongly encouraged in my opinion, that when you talk about scalability, you talk about building scalable whatever. Scalable stacks, scalable architectures, scalable anything. That you can scale down as easily as you can scale up. And that's a very important point. And that's one of the biggest points that people miss when we talk about scalability. It's what I consider kind of the reading mistake. I mean, you haven't learned that particular lesson yet, but a lot of people try to address scalability in ways that ultimately end up hurting them. Because most people, especially when they're starting off with a project, do things strangely in good intentions, but what they end up with is they end up creating a lot more problems for themselves, and sometimes they're even off the ground at all because they overcomplicated the problem, or they come up with a true scalable solution. To that end, when we start talking about, before I actually get into technical aspects and things, when we start talking about that sort of notion, organizational scalability, technical scalability, these sorts of things. Theo Schlossnagel, who's a friend of mine, that name probably rings a bell for a few people in here. He is a principal over at Omni, that's his company. And this is a quote from him which I loved when it came to this subject. The scalability marginally impacts procedure, while procedure grossly impacts scalability. And that's a very important point for all of this. If there's one thing we leave from here with, note that you guys need to make the effort to make sure that what you do in your projects, what you do in your organizations, is designed to encourage a scalable system. If you don't put that in there, it's really easy. It's relatively straightforward to do it right. Just do it and not cost a lot of money or not overcomplicate things and not make the development process painful or make it hard to write applications. But on the other hand, if you don't do it, you're going to find yourself in a situation where you will probably have to go back and really take a second look at something and the cost is not as much. So, let's talk a little bit about just that notion of planning. You have to plan. That's a big deal. You have to plan. You have to think about these things in advance. You know, there are certain tools that are going to help you plan and help you manage this, version controls, having performance goals in general. If you want to scale out to 500,000 users, and what is that 500,000 users going to do? What is that number? How many requests per second is that? How many servers are you going to need? Thinking about these things, thinking about those metrics is a very important step of all this. Scalability from a personnel system, you know, making sure you have SVN commit logs or CVS commit logs that show this, that you have a process in place to make sure that you're monitoring your employees and that the quality is still high. You're doing that ongoing process. Just developing mailing lists, creating forums internally to communicate ideas and to talk about problems and to make sure that those things get flushed out. As you grow, you need to be self-organized. You need to have tools that you don't have to yourself manage, at least day to day. And to those ends, you really need to enable them. Awareness is really the bottom line here. You have to be aware of the problems as you move forward, and you have to think about them in advance and solve them in advance before anything else is going to be successful. So, to that end, what does that mean? 110 requests a second, 100, 1,000 requests per second. If you don't actually know what performance perspective is, and this is scalability on a response measure, if you don't know what your performance measures are, you're not going to know. And they should be part of your process. They should be part of your application. They should be part of your design goals. And so, if you don't do this, there's a lot of ways it works out. A lot of companies never do this. They walk up and they build their application and become successful. I like to use a very I guess modern or at least culturally aware example of Twitter. You know, when Twitter was released, they obviously did not spend the time to really tell what their performance goals were and make sure they could hit them. They built the application, and that's what a lot of people do. And like Twitter, a lot of what happens is it's successful enough, and they take some hits, and they figure out a way to solve the problem, and then they go back and try on that solution and continue to grow. But the really successful companies, like Google, started out the gate with a plan. They started out the gate with what's going to happen in 5 years when I want to scale, you know, to unprecedented amounts of data. And for that matter, personally, I thought about these things in advance and write these things down. So you see those two spectrums, and then, but in the worst case, the reality is that if you're not careful, you can end up in a situation which is that you will have some time you're very memorable, but sometimes job ending quote of, we're just going to have to start from scratch because we can't fix the problem. There isn't a piece of duct tape that's going to help us here. So let's talk a little bit about performance metrics. Response time. How long does it take for the server to respond to a given request? It's worth noting here that response time is often misconstrued with a request time. A lot of people like to say, oh, well, my response time is 300 requests per second. That's not response time. Your response time is when the user types in the URL and hits enter to the time they get the full page. That's what the user is going to consider their response time to be. So there's a lot of things that factor into that. On an individual box level, resource usage is obviously going to be your big measures. You know, what's your CPU, what's your disk IO, what's your network IO. And then pretty quick doesn't matter, requests per second, but more than just on that one server. Because if you have a static asset server, you have this server, that server, what is the total amount of time when you look at your metrics? What is the total amount of time? Something like Firebug, there's a lot of tools out there, especially for Firefox, that will measure the exact time from the moment you enter to the time that you actually complete the request. Those are the important things you need to look at. But when it comes to an individual machine, you are correct if you say, well, request per second is 500 requests. You know, how many requests can I answer and what at the time? Being proactive is something that I see a lot of people don't do, and I've already said this a lot. But this is, it's an important thing to just kind of note that you do need to be proactive, that you do need to think about these things in advance. And then realizing that everyone has a role in performance. This is not something that is just a technical problem to solve. It is something that management of an organization needs to buy into, and they need to buy into it proactively. You need to find ways to communicate to your teams and to your bosses that it's worth the effort to go through this step. And find ways, and again going back to this quote that performing or that procedure has a gross impact on scalability. It's a team effort, and everyone does have to be involved. And so if you find yourselves in a situation that your managers, your bosses, your board, whoever it is, doesn't appreciate this, that's a very important problem to solve. It's a very important problem to solve to make sure that they get it, that if you don't put this up and down, you're kind of in trouble. So for developers, these are pretty simple things, right? Web stress tools, having tooling in place. There's a lot of great tools out there. From a strictly performance perspective, there's things like the Microsoft Web Stress Tool, Apache Mesh, HTTP Load, a lot of great tools that can throw a lot of traffic. There's some even more interesting ones if you're interested in replicating real life traffic, because sometimes that matters. I had a client while I was at end up selling tickets. And so the workflow was a very important piece of this. They needed to be able to go through the entire ordering process, and that was their measure of success. Is could I get from I want to buy a ticket to complete the transaction. So there are tools like Webload, which is now an open source tool. It used to be a commercial one. But Webload is a great tool that allows you to basically report profiles. click through the website, it records it into like a JavaScript, actually a JavaScript language construct, and then you can click play. You can fire that up and send 50,000 or whatever and distribute that across the machine and actually simulate that. Another great one, which is the commercial one, is NeoLoad, which I've had some personal experience with that allows you to do these things very nicely, track the performance and things like that. So using those tools is important on the top level, which is actually interacting with your application as a user. But then once you've identified problems, there's all sorts of tools that you need to use to figure out where the problem really is, finding that one bottleneck. Because when you talk about performance and you talk about actual web application performance, there's only ever one problem. The bottleneck that's slowing your application down right now. And so to that end, finding that bottleneck can sometimes be tricky. We'll talk about some tools that you can do that. And then testing. This should be part of your QA process as well. You need to make sure that you have those metrics and that when you launch something in production, there's a post-launch testing phase that tests that production thing. Sometime 2 in the morning, 3 in the morning, something happens, and you make sure that you're meeting your performance requirements as they were defined. Some other things to think about, just designing and scalability in general. How many times has this situation happened? Joe's like, okay, so Joe Boss goes over to his developer and says, hey, listen, I got a new idea for a product, or I got a new idea for something. And I need some feature crap. You know, it doesn't have to be pretty, it doesn't have to be super archetyped, it's got to be something that I can go sell it for. So why don't you guys go and build this tool? And just get it working and prove the concept, you know, it's a prototype. And this is one of the reasons when, especially with PHP, because PHP everyone considers PHP to be a prototyping language. So when you think about it, it's like, oh, well, we're going to go prototype it. And go and write the code, and then the next thing you know, the guy takes it to the board, and the board loves it, and it says, great, we're going to do it. And then the engineer says, okay, well then we need to go start from scratch and actually build the tool now. And no, we have the tool. We're just going to take that thing that you put together in a week, we're going to launch that into production. And then it becomes your problem that it doesn't scale. That's often what happens with dirty prototypes or the things that end up in production. And so being aware of that as a developer is important, and making sure that when you build your applications, at least you give yourself a decent chance of being able to handle these things. You know, and it doesn't take much. It's things like making sure you have a good answer for, gee, if I have to separate my reads and writes in my SQL database, I have a plan for that. Maybe I program that code, maybe I The trick is to not go too far with it, which can be equally as bad. You have only a certain amount of time to develop something, so don't waste time over-engineering it or over-engineering it to serve every potential problem you might ever encounter your entire life. But at the same time, there are little things you can do that make a big difference. And so that's important too, because I don't want to convey the message that you need to spend a ton of time up front trying to architect a hacker or something. Build the application that you need to make. And that's usually the most scalable thing. You don't need a content management system for a corporate website on a startup. You don't need to build one for sure. You know, if you're a startup company and you need a corporate website, if you really want a content management system, go pull one off the shelf. You know, go use Google or something else. But chances are that off the bat, you're going to be perfectly happy with static HTML. That's not sexy. That's not cool. You know, that's not something that you can totally get into, but it means a lot. It's a big difference. And, you know, I've always distinguished the difference between a good engineer and a really good architect by being able to swallow that piece of pie and say, you know what I really need to build here is just a stupid form processing thing. I don't need to build this giant database. So those are things that are very important. Now let's talk about some other very kind of specific things. These are things that I've specifically seen in numerous clients, and they're problems enough that I just want to highlight them. And if you're using them in your organization, I'll talk about what you might be able to do to fix them. The first one is network file systems. A lot of organizations like to release their code, meaning that they've got 5 servers, and so they're like, gee, how do we distribute this code base to these 5 servers? I don't want to put 5 copies of the code out there. That doesn't make any sense. So I'm going to set up an NFS, and this NFS is going to be in my production servers, and I'm going to just copy the code once, and then do an SQL export with this NFS, and then all the web servers are going to go use it. This seems like a reasonable idea, but from a performance perspective, it's really, really not going to work. NFS, GFS, whatever it is really loose. It's especially compared to local file system, it's amazingly slow. And there's tons of problems when it comes to if you're doing any sort of writing in an application. If you're writing anything in the file system and you're writing in NFS, the distributed like the slow locking and the concurrency just goes right out the window. Not to mention it doesn't work right. And so you end up with a lot of problems, and you usually don't realize those problems until it's way too late to fix them. Because when you first do it, it doesn't make sense, and then you get 500,000 users and something like that. So avoid using NFS. How do you deploy the code base instead? Well, use RSync. Keep it simple. That's my personal opinion. I mean, there's all sorts of tools out there that could do deployments, and honestly, I don't think one is necessarily better than the other. There's all sorts of ways you can solve it. You can create an RPM and ship off an RPM. You can use a Debian, kind of an activate sort of tool. I've seen that. Or you can just use plain old RSync and just set up a staging server that literally is a production server that's not in production. So it's exactly the same thing. Like at any given point in time, you can turn on that server as part of your full production network. And then just rsync that box straight out there. It works, it's simple, it's fast, it's reliable, you can put it out forever. That's always what I recommend. Now, there are certain circumstances where runtime updates. Do you have a question? No. Runtime updates. And by runtime updates, I mean, like, what do you do with file uploads? This is a really interesting problem to solve. And it unfortunately has no really good answer. So don't search too hard for it, but there are some things you can do depending on your needs. And this is part of the trade-off between business and business and architecture. And there is that trade-off because when you have something like I want to upload a file, I had a client that ran band sets for different bands, and that was a file where they had this kind of generic architecture for building music fan websites, and they wanted to be able to have people upload custom content, whatever architecture or something else that they drew for their favorite band, and then be able to share that with other people. And a few servers. How do I get that file around? It took a lot of convincing, but ultimately the right answer was because of their scalability issues, their performance and their requirements, you couldn't do something like NFS, which is the easiest answer. I know I just said don't use NFS. Now I'm saying if you got to use NFS, be very specific where you use it. Set up one directory, not your entire code base, but there's one directory where you're going to write the file to once, and then everyone else is going to read it. That's an option. You can go farther than that, and then not only read the file off of NFS or serve it off of NFS once, but then you serve it off of NFS and then write it to the local file system immediately after. And I'll show you a design pattern that you can adapt from building web apps that will help you do that. But the other option is to make compromises with the business requirements. To say, okay, well, you can upload it to this one server, and then it's just not going to be immediately available within 5 minutes, 10 minutes, whatever. It will appear on the website after you upload it and give it time to actually send it to the source. So there's all sorts of tools you can do there. You can always just stick it in the database too. There's nothing wrong with that, but some people find it to be kind of annoying to just dumping it to the database. They don't like having that sort of binary data in them, but it is an option. I.O. buffers. When it comes to performance itself, especially when you get bigger and bigger and higher and higher numbers, understanding I.O. buffers and actually using them appropriately becomes a big win quickly for all aspects of your application. If you're sending 498 bytes of data in your response request to the end user, but your write blocks are only 496, that's a that's a huge performance problem under high load, because that means that for every time you respond, you actually have to respond over 2 blocks of data instead of 1, which means that there's a lot more kernel work, a lot more stuff, and the second block of data is really only 2 bytes. You can solve this problem using a few different ways. You can you can adjust your output buffer to match your system IP size with TCP buffer size, and that works. But chances are that on most Linux distributions, like the vanilla distributions that most people use, those TCP buffers are very, very conservative. They're usually very small, especially for modern hardware. They're kept small intentionally because they want to make sure that it works first and not tweak later. So matching those things is huge. If you're going to have an output buffer size of 496K or 496 bytes, make sure your TCP buffer is at least 496 bytes, and then you've got a one-to-one connection there. So you've got to be solid in the pipe instead of having the kernel juggling things around. And that solves a few problems. And it solves the user experience problem, because it means that less packets per day, you can go and wire everything else. And when you do it, just be careful. Be mindful of how much RAM you actually have. You increase that buffer, it's got to be stored in memory, which means that you're just going to make sure you've got enough memory. And usually this numbers come with experimentation. You say, well, file size that I'll put out is 15K. So how far do I want to go with this? If I got a box with a ton of memory, I could maybe even set my TCP buffer to half that, 700K, maybe even 15K, and set my output buffer the same, and get a lot more performance out of your I/O. Speaking of RAM disks are actually a really nice way to improve performance. It's kind of analogous to reasonable. There's a lot of ways to share memory. Just create a RAM disk and mount it, and then write to it for sharing across HTTP requests or for anything that needs to be manipulated quickly. So a great example of where a RAM disk could help a lot is, I don't know Twitter's architecture, but Twitter could potentially use something like RAM disk to improve performance, because they could take the graph that represents updates and things, and they can store that either in shared memory, which would be more ideal, I guess, but you could even store it in RAM disks in a set of files, and have these relationships all represented in RAM and manipulate them using the file system, and then flush those RAM things to disk as necessary. So, and that could help a lot. There's a lot of examples of where that makes sense. Except the file upload into a RAM disk is not a bad idea either if you're doing a lot of it. And you're doing it consistently just because you're writing the memory and it's a temporary file anyway. So keeping that in mind and keeping that as a tool, a lot of people don't realize that it's a perfectly reasonable alternative. And to that end, it's a perfectly reasonable alternative to actually create data structures. And this kind of goes back to some of my less known clients, and they're all porn companies. But the porn companies love to do these sorts of things. And it seems really broken and archaic, and it makes you kind of cringe a little bit at first as an architect or somebody who's kind of a technology purist, especially if you want like a nice, solid, something impressive sort of architecture. What they like to do, especially for these order sites, where they're collecting orders and collecting credit card data on these ridiculous scales, they will literally just write the order data to a flat file on the disk with a random name, and then just stick it in the directory. And that's what they do to collect the order information when the payment gateway goes out. And they'll do it at 50 orders a second or whatever their ridiculous number is. And it sounds like a bad idea, but it's actually not that at all. So what they do is they just write the disk. It's a write operation. One-time thing, they can do it in one swoop, store it, they have the data, and then what they do is they run back and processes later that actually will process all of those files one by one, do the actual order at some later point in time when the game gets back up, and move on to the flow. So, think about those things. Think a little bit out of the box when you do performance and things like that. It's a pretty interesting approach. Speaking of bandwidth, there's a few ways you can optimize your bandwidth. This is actually less and less of a problem nowadays, because for a web app itself, I don't think bandwidth is an issue issue as much as video, but there are, I guess, a few cases where reducing your total file size can be a lot. Because there are people who still pay per gigabyte of traffic, and you've got a lot of users which like counts. So there's a few ways to go about it. Commodity flag is a simple one. Install that into a patch if you want to do it. If you want to handle it at the PHP level, which is only going to help you in PHP, then you can use output compression on the zlib and just turn that on with your zlib extension. And you can also get kind of clever and use something like tidy if you want to. And what tidy will do is it will go through your output and get rid of all the white space, everything that makes your HTML readable to a user. It gets rid of it pretty much, or at least it can be configured to, so that the only thing you send is the part that the computer needs to actually render, and dropping property attributes and things like that, or joining classes together and all that sort of stuff. So there's a few ways to manage bandwidth stuff in PHP apps, and then PHP itself can also be configured for state. And these are just some INI directives that if you wanted to turn off, you use them, or you're concerned with high performance. These are all things I would mess around with to some level. Turning on things like register globals or auto global JIT. A lot of these are all about the idea of let's make every request faster. So auto global JIT is actually kind of a big one, especially if you have a lot of environment variables or you deal with a lot of things like your server super global, that's really loaded with stuff. And all that means is typically in PHP, when you look under the hood, those super globals are created at the start of the request automatically. So all the memory is allocated for them, everything is there, and there's a fair amount of processing that goes into creating that particular super global, whether you use it or not. And by turning off auto global JIT, it basically delays that to the point where you're actually need it, which you really got it, but sometimes you don't need it at all. If you don't use the server super global, then auto global JIT will give you a performance increase because it won't spend the time to compile it in advance, even though you didn't use it. And then if you do use it, you have the same performance impact in the sense that you're going to have to compile it sooner or later anyway, but at least you won't compile it. So that's a nice one. And again, a lot of these have to do with automatic variable creation. PHP, register global can be turned on no matter what. But there's a performance reason for that because you don't want to figure out variables for no reason. And always populate all post data, unless you're using it for no reason, you have to keep it on. Sessions, something like use trans did is actually a big one for most of all PHP performance cases. What that does is it's going to have to go through and parse your output before it gives it to the user, and it's going to have to go find everywhere to find a URL, and then it's going to have to tack on a stupid session. Not to mention being insecure, it's also just a waste of processor settings. It's not hard to just build your application that you're not going to rely on sessions. And then awkward buffering, garbage collection devices, these are all things that I've already talked about before. Garbage collection device, so that's just how often you give it to the data. When your sessions expire. So, blocking calls. Blocking calls are probably, I would describe a blocking call performance problem to be the number one major performance problem in the application. Now, that said, it's kind of cheating a little bit because usually the biggest performance bottleneck at that is the database server. 9 times out of 10, it's a bad schema that's causing a performance problem with an application rather than a blocking call. But I would argue that, with that query takes 10 seconds to return, you're effectively blocking PHP. So, what is blocking PHP? What is a blocking I/O call? There are certain things when it comes to input and output that your application can do without affecting the overall runtime of that particular script. It can do this, it can do that, and it doesn't have to wait for feedback. Blocking calls are basically when, for instance, you try to open up a remote URL and you're having trouble resolving the domain, like your DNS server is down. And we've all seen this happen in Firefox, right? I can't resolve it. What happens with Firefox when I type in a domain, I can't do it, or it doesn't resolve right away. And it's not like the server just was down and it didn't exist, it just little spinning thing goes forever, right? Then maybe 30 seconds later, it comes back and says, oh, can you find the website? That's a blocking call. And the same thing can happen in the PHP application. I have an example. One example is I have a client that, or I had a client, I should say, that they use a third-party webmail provider as part of their online community. So they want to provide domains, emails and domains for their specific application. And so they went off and found a provider. And they use basically web services and remote URL sort of things to integrate that webmail into their application. Now, this was a big application. I mean, this application did 50 logins a second. For every minute it was down or something, it lost the company, on average $10,000 an hour. I mean, these are the types of things that are a big deal. Big deal. What happened that one day, that email provider just died, right? And it just sort of went away for, I think it was 2 hours. Something went wrong on their side and the servers went away, but they didn't really go away, they just kind of stopped working. And it brought down the entire application. Because what happens is you have an Apache process which has a request come in. That request is dished off to PHP. PHP starts executing code, and at some point in that execution, it needs to go fetch a URL. Now, it goes and tries to fetch a URL, and say the URL is really slow to respond. What's going to happen is PHP is going to stop on that line of code until that URL comes back, or it times out. And when it stops there, nothing else is happening. Not only with that PHP script, but the Apache child process, whether it's a thread or a query fork process, that Apache child no longer is doing anything either. It's waiting on PHP and PHP is waiting on the stupid block of call. And so what ends up happening is that Apache can't handle another response. And you get a domino effect. Because then the next request comes in. And it's the same problem. And now you got 2 Apache children who aren't handling requests. And if you've got any sort of traffic, it takes about a split second, and you end up with all your Apache children sitting around twiddling their thumbs, waiting for some stupid URL to respond, and the entire site comes down. And then on top of that, you get all the performance, you hit the top edge of the performance of your hardware, and it can take hours for your servers to recover. It's a pretty bad thing. You might as well try to scale an application that has a sleep 30 in it. In order to, if you want to kind of draw an analogy, it's very bad thing to do. And so how do you prevent this? Well, there's actually more tools now than there were when this particular client faced the problem. The way the client resolved the issue was they basically negotiated. They did it through business deals. They negotiated with the email provider saying, "Hey, listen, I want an SLA for you. If you go down for whatever, here's a formula for how much money you owe us for every second you're down." And that's how they compensated for it. Basically making for their lost revenue. But some other more practical solutions, if you can't go making those negotiations, is don't use blocking calls in your application. I know that sounds really kind of silly, but try to just avoid them and just be aware that you're doing that. Making sure, or at least don't put them in heavy aspects of your application. Don't put them on your front page. Put them somewhere where it's lower traffic and you have to use them. And make sure you do things if you're going to use a blocking call. Set your timeouts intelligently. Make sure that your HTTP request isn't going to, by default, almost every HTTP request object out there on the planet is going to wait 30 seconds for your application, for that URL to return and for things to work before it decides to give up. Set that to like 1. I mean, set it to 1 second. I mean, honestly, we're in the 21st century. It shouldn't take more than a second to get some sort of response before something times out. No more than 5 seconds total. And give you at least feel help. But I don't think if you set the 5, you'll have a better user experience. But if something really went wrong, you'll probably take on your site anyway. If you set the 1, you might have a chance of keeping your site up without that particular feature that you're getting to that remote URL. So the best way to do it though is to take this entire process out of the web request. And you do it as an asynchronous operation. That's what when I did represent not to plug product too much, but Zen Platform, which is Zen kind of enterprise server thingy, they have in the new version something called Java, which is basically an asynchronous PHP engine. I can write code over there to make my URL request, but then when it comes to actually the web request, I have a very reliable, very quick, hey, go do this. And it's just like, as I'm handling the request going to my logic, I can go point at that computer over there and say, hey, you, go send that email. Or hey, you, go update your statistics. And that process runs behind the scenes. It can take as long as it wants. And all I did was instruct something else to go do something that I can with my request, which means that I don't have that problem. And it's actually a very, very nice tool for those sorts of situations. Caching in general, failing in cache is a big one. Just people, the only thing I'll say about caching, because I feel like caching has been beat to death at this point, cache. You must cache. The only thing I would really say is that here's a little example, right, about caching. If you have one page load that does 2 queries per request, and you cache that query for 5 seconds, which isn't a long time. Most people, 5 seconds is a perfectly acceptable time in order for you, as a user, you expect the data to be updated. And if it only takes 5 seconds, that's really not going to be something that most users are going to require. And so people don't realize how much they can cache. And when you do that, if you've got 20 requests per second, and you've got 2 queries per request that you can cache, you're going to save yourself 4,000 queries a second just by caching it for 5 seconds. So there's a lot of examples where just a minor usability, a minor thing where you have to wait 5 seconds for that record to update, has a big impact on performance. So keep that in mind. Using opcode caches is a big one. So PHP 6 is going to have this one built in, but the easiest win in the world to optimize your PHP scripts, if you're not going to know it is, get an opcode cache. Go buy Zen Platform, go download ABC, go to whatever tool really works for you. Get an opcode cache. That's going to typically save you 25% of your execution time out of the box with absolutely no changes or purpose. So, like I said, PHP 6, if and when it ever comes out, we'll have this built into it. That's part of the plan, but there's nothing stopping you from using that. Semi-static caching. This is a cool one. This is a design pattern that we'll go over. So a lot of people have this, especially in content management systems, where you have something like a blog, right? And you must show a specific article on the page, and that's a page by itself. So you'll have something like show article.php, and a little question mark, now equals 5. And you say, give me, and that script, you can already imagine what it does. It just goes to the database, pulls out the content, and creates the page for that. Like the Amazon product page, except it's customized to specific content. Now, instead of doing that, that's the way it's typically done. Instead of doing that, I'd like to propose that instead of generating HTML, which is the final output, why not generate PHP code and write that to disk? And that sounds a little weird. But when you write PHP code to disk, you don't write the entire script. You write as much static stuff as you can based on that database entry, but then you leave only the PHP script that needs to be customized. And this is the difference from when you want to do full page caching, which is literally just caching the entire output. That doesn't always work. Because if I have a string hello John on top of my HTML page, I can't full page cache that page. Because hello John would be full page cached for Joe when he went to request that same article. So instead you generate a file that has a little chunk of code that fills in John, print real name, but then the entire thing is actually HTML. And you use mod rewrite to make this process entirely transparent to you as a developer and to the end user as well. So instead, you write these PHP scripts. You write one to the articles directory and you call 5.php, the ID number, 5.php. And then you create a rewrite rule such that example.com/articles/5.php will automatically rewrite itself to show articles.php with an ID parameter of 5. Now, the interesting thing about this is the way rewrite works is if the file doesn't actually exist, rewrite will turn off. But if 5.php exists, it's just going to serve 5. So what you end up with is a very, very effective transparent, semi-caching mechanism, where the browser requests article.5.php. If the file exists, it just executes it. And when it executes it, there's no database calls in there. The data is already been retrieved and statically hard-coded in the PHP document. So it just dumps out that text and does whatever little PHP logic it needs to do to add the customization. But for the most part, you don't even touch the database. And then the browser uses it as content. Now, if the file doesn't exist, it executes the rewrite rule instead, which then executes show article.php by id equals 5. That show article request will write 5.php to disk, so the next request won't have to execute it again, and then execute 5.php, which is a very, very cool kind of thing, especially when you're doing a lot of content. There's a lot of ways you can apply this. And the cool thing about it is that flushing and cache is really easy. If you want to update that content, just delete the file. And it will automatically just regenerate the file next request. So that said, core database design is another one. I think we can skip over that because we're running out of time. I don't want to spend much time on that. Although I do want to say something that's really, really important when it comes to, especially if you use MySQL replication. This is a huge problem. First off, and the problem I have, first off, when you build an application, you're going to use MySQL and you want to scale it, and you're not planning on using MySQL cluster or MySQL proxy, which a lot of people don't want to do. Make sure you develop your application so it knows the difference between what's a write and what's a query. It's very simple to do. You have a little flag, then you can put on a query, make a different method call. You have query, query, write, whatever it is. Just make sure the application has a way to go. So that at some point in the future, if you ever need to split the two apart so that you can syndicate the data, you can do that. And then here's a big one. Never, ever, 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 ever use PHP to determine database scale. I don't care what it says in the book. I don't care what your friends told you. PHP has absolutely no business determining where to connect to the database. PHP should connect to a host name. That's in your host file or in the DNS server somewhere, whatever. But don't try to be clever and say, I'm going to make a redundant failover system and I'm going to put that into PHP. So when my master server goes down, it will automatically turn around and connect to the other master and my website will continue sitting on there. Because that's going to blow up in the face. And the reason that blows up is what happens if MySQL goes down for a second and comes back up, right? So now you've got a situation where you have a MySQL server here and then you've got a hot standby ready to start taking queries. And they're synchronized and they stay in sync. And then you're writing to this one replicates to that one. And the idea is PHP is going to come in and if it can't connect to the primary database, it's going to connect to the secondary. That sounds like a great idea, but what happens if MySQL just nothing else? Or what if it refuses one request? Now remember, you've got an Apache running, and that script that's making that decision is running 50 times in 1 second. And say in that 1 second, it hiccups. Now you've got half of the requests that went to the right database, the primary master database, and wrote data. And then the other half of the requests that caught the hiccup have now decided that they don't like the primary database, and now they're ready for the secondary database. And now you've got a complete synchronization issue, and now you have to take your site down to the database. Or it's a pain in the butt just to fix it. Now you've got to manually get all these things back in sync. Don't do that. Instead, use something like MySQL proxy. That's the right answer. Use something out of process. Using MySQL proxy is the modern solution. What I always recommended was instead just connect to a host name, even if you don't have a DNS yourself. Connect to a host name that's in your host file, and then when you have something that's monitoring your database, have that be out of process. Have that be a cron job that pings the MySQL database server every 2 seconds, and if it fails, it modifies that host file. That way, all of the PHPs will concurrently switch over to the next file, instead of having this kind of, oh, this one's connecting here, this one's connecting there. That's kind of what you want to avoid. For this piece, I'll skip all the front matter explaining it, but it's something really cool from a scalability perspective. This is actually from Flickr. This is what they did at Flickr. I don't know if this is what they still do, but Flickr had a problem where they need to have a really, really high concurrency on their writes. They obviously did a lot of data, they're a huge application, but they wanted full text searching as well, and they were using MySQL, and they didn't know what quite to do. Because if you're doing a lot of writing, you need to use IndioDB for your database, because that's row level locking. You know, if you use MyISO, it's table level locking, and that's going to blow up in the face, at least at that level. But MyISO is going with the full text searching. So how do you solve that problem? Well, a lot of people don't realize that if you're setting up a master slave replication farm, there's no contract saying that you must maintain table types across replication. So basically what happened was, or what they decided to do was, they had their primary slave, which was an IndioDB that they were reading from. And then when they wanted to do full text searching, they syndicated that off to another database server where that same table was no longer an IndioDB table, it was a MyISO table. And that MyISO table is what they connected to do the full text searching. But when they did all the writes and all the reads for everything else in the application, they connected to their normal IndioDB tables. So very cool stuff, very useful to know, because a lot of people don't realize you can do that. Using SQLite, how many people know or use SQLite? That's like 3 times as much as last time I gave this talk. That's cool. Using SQLite is great in PHP to create your web apps. Think about it, especially anything that's a lookup table, anything that can be represented as a lookup table. For example, a product catalog is an example of this 3 times in mine uses for. And the principle is very simple. You just, instead of hitting MySQL for your product catalog, since your product catalog doesn't update, maybe it updates once a day even, that's not a big deal. Take that MySQL data, export it into an SQLite database, and put an SQLite database in each one of the servers. And then in your web farm. And you have PHP using that SQLite server for that data, and then just update that data on whatever semi-regular basis you need to update it on. Because MySQL is going to run amps off of, or SQLite is going to run amps off of MySQL on reads. But don't try using it for writing. It's when you write to the SQLite database, it blocks the file, because it's a file-based sort of thing. And as a result, you basically lock the database. So I think we did some numbers on it. You can get like 700 writes a second out of it. So don't use it for writing, but great for lookup tables, and great for just, if you want to use it for lookup tables, just syndicate it down on top of the original file. And I'm totally way over. So I'll put the full slides on here. I think I've gone through about 20 scalability mistakes instead of 10. But I know you guys want to get going, so I will end it here. I'll put my slides on my website, which is top10ScalabilityMistakes.org, and you can go ahead and download that. But I did want to stop and say just some final thoughts. When it comes to scalability, again, make sure you realize that scalability is more than performance. Make sure that scalability is something that goes up and down. You have to be able to afford to make the application to begin with. So don't spend too much time building stuff that you might need in the future. But that said, don't spend too much time, or spend enough time to make sure that when you need to build that application in the future, you haven't seen yourself in the overall. And finally, I guess is just remember that with any application, there's only ever one problem. So that said, if you guys have questions, I'll stay up here for a minute and field them. But otherwise, thank you very much.